Good day everyone and welcome to our presentation. I'm delighted to introduce our paper, Topicwise Separable Sentence Retrieval for Medical Report Generation, authored by Junting Zhao, Yang Zhou, Jihao Chen, Huazhu Fu, Liang Wan, Zijie Zhao, and L Chen. We've embarked on a journey to revolutionize medical report generation, addressing the overlooked rare topics and enhancing the accuracy of these crucial documents. Stay tuned for an intriguing exploration of our innovative approach and its impressive results. Begin a frame title at key highlights, begin itemize, item key motivation, begin itemize, item our work is driven by the need to address a significant challenge in medical report generation, the overlooking of rare topics due to the long tail distribution of data. We aim to ensure that these rare, yet crucial, medical observations are not missed out in the reports. Our ultimate goal is to enhance the accuracy and comprehensiveness of medical reports. We achieve this by developing a method that not only understands common medical observations, but also effectively identifies and includes rare ones. This ensures a more complete and accurate representation of the patient's condition. End itemize, end frame. In this slide, we delve into the key issues that our research addresses. Firstly, we've noticed that existing retrieval-based report generation methods have a tendency to favor high-frequency sentences, often neglecting the less common, low-frequency ones. This can lead to critical findings being overlooked in the generated reports. Secondly, these methods often struggle to understand the relationships between queries and topics. This results in the generation of repetitive sentences with identical semantics, which can lead to confusion and redundancy in the reports. Our research aims to tackle these issues head-on, ensuring a more comprehensive and accurate generation of medical reports. Moving on to the key highlights of our research, we've developed a method that successfully addresses the issue of rare topics being overlooked in medical report generation. This is achieved by separating common and rare topics, allowing us to generate more accurate and comprehensive medical reports. Our Abstractor module plays a crucial role in this process. It reduces visual noise, which in turn aids the topic decoder in better understanding the visual observational intents. Lastly, we've introduced the Topic Contrastive Loss, or TCL for short. This innovative approach effectively aligns similar semantic queries and topics, reducing confusion in matching. In essence, our method not only improves the accuracy of medical reports, but also ensures that no critical information is overlooked, regardless of how common or rare the topic is. This is a significant step forward in the field of medical report generation. In this slide, we're going to delve into the key contributions of our paper. We've introduced a novel method called Topicwise Separable Sentence Retrieval, or teaser, for generating medical reports. This method is unique in its approach to handling queries. We've divided them into two categories, common and rare. The common queries are designed to match with frequent medical observations, ensuring that our method can handle the majority of cases effectively. On the other hand, we've also considered the importance of rare, low-frequency findings. Our rare queries are specifically designed to capture these crucial details, ensuring that no important information is overlooked. This dual approach allows our method to generate comprehensive and accurate medical reports, regardless of the frequency of the medical findings. In this slide, we delve into the key highlights of our proposed method. We begin with the Vision Transformer, or VIT, which is used to extract dense visual features from a radiological image. These features are then streamlined by an Abstractor, which removes any redundant or irrelevant information, leaving us with more compact, task-relevant visual features. Next, we introduce the Topicwise Separable Encoder. This component takes these refined visual features and generates diverse topic embeddings. These embeddings play a crucial role in identifying the most suitable sentences for report generation from our training set. Lastly, we discuss the Topic Contrastive Loss, or TCL. This innovative feature aligns similar semantic queries and topics, effectively reducing confusion in the matching process. This ensures that each query learns a unique topic, enhancing the accuracy and comprehensiveness of the generated medical reports. In essence, our method provides a robust and efficient solution for medical report generation, addressing the challenges of conventional retrieval-based methods and setting a new standard in the field. Begin a frame title at key highlights, begin itemize, our method, teaser, uses a vision transformer to extract dense visual features from radiological images. Item, the Abstractor module removes irrelevant information, creating compact, task-relevant visual features. Item, the Topicwise Separable Encoder generates diverse topic embeddings from these features. Item, we separate queries into common and rare categories to ensure we capture both high-frequency and low-frequency medical observations. Item, our Topic Contrastive Loss ensures each query learns a unique topic. Item, the final report is generated by retrieving the best matching sentences from the gallery and removing duplicates. Item, our method addresses the issue of conventional retrieval-based methods being unable to learn rare topics. Item, we achieved state-of-the-art results on 2 publicly available datasets, including an 11% improvement on the MIMIC-CXR dataset. End itemize, end frame, begin frame, frame title our proposed method. Teaser, begin a mini page, T is 0.5 line width. Begin itemize, item teaser begins by extracting dense visual features from a radiological image using the vision transformer. Item, these features are then refined by the Abstractor module, which removes redundant and irrelevant information. Item, the Topicwise Separable Encoder then generates diverse topic embeddings from these refined features. Item, these embeddings are used to identify the most suitable sentences from the gallery for report generation. Item, we also classify queries into common and rare to ensure that no crucial information is overlooked. Item, finally, the Topic Contrastive Loss ensures that each query learns a unique topic. End itemize, end a mini page, H-fill, begin a mini page, T as 0.5 line width, begin a figure, centering, include graphics, height equals 0.8 text height, SRC task underscore execution extracted underscore paper underscore data, 2405.04175v1, figures, 2405.04175v1 figure 2:1.png, caption as schematic illustration of teaser, end a figure, end a mini page, end frame, begin frame, frame title our solution, the teaser method, begin a mini page, T as 0.5 line width, begin a figure, centering, include graphics, height equals 0.8 text height, SRC task underscore execution extracted underscore paper underscore data, 2405.04175v1, figures, 2405.04175v1 figure 5:1.png, end a figure, end a mini page, H-fill, begin a mini page, T as 0.5 line width, begin itemize, item figure. This visualization showcases the reports generated by our teaser method compared to other leading methods. Notice the color-coded sentences. Each color represents a different topic. The underlined sentences are the rare observations our method successfully captures. Item, our solution, the teaser method, uses a vision transformer to extract visual features from radiological images. These features are then condensed and made more task-relevant by the Abstractor. Item, the Topicwise Separable Encoder generates diverse topic embeddings from these features, which are used to retrieve the most suitable sentences for report generation. Item, we've also introduced a strategy to separate common and rare queries, enabling us to capture both high-frequency and low-frequency medical observations. Item, the result, more accurate and comprehensive medical reports. End itemize, end mini page, end frame. Let's take a closer look at the figure on the left. This visual comparison showcases the reports generated by our teaser method and other state-of-the-art methods. You'll notice that sentences shaded in the same color correspond to the same topics. The underlined texts highlight the rare sentences that our method is able to capture, which is a significant advantage of our approach. Now, moving on to the limitations of existing approaches. Current retrieval-based methods tend to produce high-frequency sentences and often overlook low-frequency ones. This can lead to crucial information being missed out. Additionally, these methods often struggle to learn the relationships between queries and topics. This results in repetitive sentences with identical semantics in the reports, reducing the overall quality and usefulness of the generated reports. Our teaser method addresses these limitations, providing a more comprehensive and accurate solution for medical report generation. Let's take a closer look at our proposed method, the Topicwise Separable Sentence Retrieval, or teaser for short. This method is unique in that it categorizes queries into 2 distinct groups, common queries and rare queries. Now, what does this mean? Well, common queries are designed to match with common medical observations, the kind of observations that we see frequently in medical reports. On the other hand, rare queries are designed to capture descriptions that are specific to low-frequency yet crucial findings. If you look at the figure on the left, you'll see a comparison and visualization of reports generated by our teaser method and other state-of-the-art methods. The sentences, shaded in the same color, correspond to the same topics. The underlined texts highlight the rare sentences that our method is able to capture. This illustrates the power of our method in capturing both common and rare medical observations, thereby generating more comprehensive and accurate medical reports. Begin a frame. Frame title our proposed method. Teaser, begin a mini page. T is 0.5 line width. Begin itemize, item figure. Schematic illustration of teaser. It shows the process from inputting a radiological image to generating a complete report. Item process overview, begin itemize. Item, the vision transformer, VIT, extracts dense visual features from the input image. Item, the abstractor removes redundant information, resulting in compact, task-relevant visual features. Item, the Topicwise Separable encoder generates diverse topic embeddings using these features. Item, the most suitable sentences are identified from the gallery for report generation. Item, the system classifies queries into common and rare, addressing the issue of overlooking rare information. Item, the Topic Contrastive Loss ensures each query learns a unique topic. End itemize, end a mini page, hfill, begin mini page, T as 0.5 line width, begin a figure, centering, include graphics, height equals 0.8 text height, src task underscore execution, extracted underscore paper underscore data, 2405.04175v1 figures, 2405.04175v1 figure toot1.png. Captiona, the framework of the proposed teaser, showing the process from visual feature extraction to report generation. End a figure, end a mini page, end a frame, .. On your left, you'll see a visual comparison of reports generated by our method, teaser, and other leading methods. Each color shade corresponds to a different topic within the reports. What's particularly noteworthy is the underlined text. These are rare sentences that our method has successfully captured. This highlights teaser's unique ability to not only handle common medical observations, but also rare, yet crucial findings. This is a significant advancement in the field of medical report generation, addressing a long-standing issue where rare findings were often overlooked. Our method ensures a more comprehensive and accurate report, improving the overall quality of healthcare. In this slide, we delve into the related works in the field. We focus on retrieval-based report generation methods. These methods operate by searching through a sentence gallery to find sentences that are relevant to the input query. They construct a coherent medical report using the retrieved information. This approach is different from generation-based methods, as it does not require training the model from scratch. Instead, it focuses on matching medical findings in the image with the corresponding textual descriptions. This approach has shown great potential in the medical report generation task, outperforming many generation-based methods. However, it's important to note that these methods tend to produce high-frequency sentences and overlook low-frequency ones, which can lead to overlooking critical findings. In the next slide, we will discuss how we address these challenges in our research. Begin a frame. Frame title our related works, begin itemize, item detailed discussion on TRAN-SQ. Begin itemize, item TRAN-SQ, a retrieval-based method, leverages the transformer encoder, decoder architecture to learn topic-level image representations as queries. Item, it retrieves relevant sentences from a gallery of embedded sentences in the training set to construct the final report. Item, however, it tends to produce high-frequency sentences and overlooks low-frequency ones due to the long-tail distribution of data. Item, this leads to a lack of comprehensive understanding of rare topics, which often indicate critical findings. Item, moreover, it struggles to learn the relationships between queries and topics, resulting in repetitive sentences in the reports. End itemize, end a frame. Begin a frame. Frame title our proposed solution. Teaser, begin itemize, item addressing the limitations, begin itemize, item we introduce a Topicwise Separable Sentence Retrieval method, teaser, to tackle the challenge of overlooking rare topics. Item teaser separates the retrieval of common and rare topics, ensuring a comprehensive understanding of all medical findings. End itemize, item enhancing semantic alignment, begin itemize, Item, we propose the topic contrastive loss, which aligns queries and topics with similar semantics, reducing the confusion in matching. End, itemize. Item, improving visual understanding. Begin, itemize. Item, we adopt the Abstractor module to compress visual features and eliminate visual noise, aiding in better understanding of visual observations. End, itemize. Item, achievements. Begin, itemize. Item, our method achieves state-of-the-art performance for both NLG and CE metrics on two well-known medical report generation benchmarks. End, itemize. End, itemize. End, frame. Moving on to related works, we've identified a significant issue with the relationships between queries and topics in existing methods. These methods often struggle to accurately learn and understand these relationships. This shortcoming leads to a problematic outcome: the generation of repetitive sentences in the reports. These sentences, while different in their structure, carry identical semantics, leading to redundancy. This redundancy not only affects the quality of the reports, but also hampers the efficiency of the system. In the next slides, we will delve into how our proposed method addresses these issues and improves upon the current state of the art. In this slide, we delve deeper into the technical details of our proposed method. Teaser: this method is unique in its approach to sentence retrieval, as it categorizes queries into two distinct groups: common and rare. The common queries are designed to match frequent medical observations, such as pneumothorax and consolidation. On the other hand, the rare queries are responsible for capturing descriptions of low-frequency, yet crucial findings like supraspinatus and osteoarthritis. The figure on the right provides a visual comparison of reports generated by our teaser method and other state-of-the-art methods. You'll notice that sentences shaded in the same color correspond to the same topics. The underlined texts highlight the rare sentences generated by our method, demonstrating Teaser's ability to effectively capture and generate rare information. This unique approach allows Teaser to generate more accurate and comprehensive medical reports, addressing the issue of conventional retrieval-based methods being unable to learn rare topics. On your left, you'll see a visualization comparing reports generated by our teaser method and other state-of-the-art methods. Notice the sentences shaded in the same color. These correspond to the same topics. The underlined texts highlight the rare sentences generated by our method, a unique feature of our approach. Now, let's delve into the technical details of the teaser method. It begins with a vision transformer, or VIT, which extracts dense visual features from a radiological image. These features are then fed into an abstractor, a module designed to remove redundant and irrelevant information. This results in sparse visual features that are more compact and task-relevant. These features are then processed by the Topicwise Separable encoder, which generates diverse topic embeddings. This is where our novel Topic Contrastive Loss, or TCL, comes into play. TCL aligns similar semantic queries and topics, significantly reducing confusion in matching. This method allows us to generate more accurate and comprehensive medical reports. In this slide, we delve deeper into the technical aspects of our proposed method, teaser. On the left, you can see a visualization that compares the reports generated by our method and other state-of-the-art methods. The sentences shaded in the same color correspond to the same topics, and the underlined texts highlight the rare sentences generated by our method. Now, let's talk about the Abstractor module, a key component of our system. This module plays a crucial role in reducing visual noise from the radiological images. By doing so, it aids the topic decoder in better understanding the visual observational intents, which is crucial for generating accurate and comprehensive medical reports. On the right, you can see a figure that visually represents the process. This figure provides a clear illustration of how our method works, from the extraction of visual features to the generation of the final report. In essence, our method not only generates more accurate reports, but also addresses the issue of conventional retrieval-based methods being unable to learn rare topics. This is a significant step forward in the field of medical report generation. On this slide, we delve deeper into the technical aspects of our proposed method, teaser. As you can see in the figure on the right, we have a visual comparison of reports generated by our method and other state-of-the-art methods. The sentences shaded in the same color correspond to the same topics, and the underlined texts highlight the rare sentences generated by our method. This visualization clearly demonstrates the effectiveness of our approach in generating comprehensive and accurate medical reports. Now, let's talk about the Topic Contrastive Loss, or TCL, a key component of our method. The TCL serves two main functions. Firstly, it aligns similar semantic queries and topics, ensuring that each query learns a unique topic. Secondly, it reduces confusion in matching, making the retrieval process more efficient and accurate. This is a crucial step in our method, as it allows us to separate common topic queries from rare ones, addressing the issue of conventional retrieval-based methods being unable to learn rare topics. In essence, our method not only improves the accuracy of medical report generation, but also ensures that no crucial information, no matter how rare, is overlooked. This is a significant step forward in the field of medical report generation. On this slide, we have a visualization comparing the reports generated by our method, teaser, and other state-of-the-art methods. The sentences, shaded in the same color, correspond to the same topics, and the underlined texts highlight the rare sentences generated by our method. This highlights our unique approach to the problem of medical report generation. We've formulated the problem as a retrieval-based task. The goal is to find the most relevant sentences for the input query from a sentence gallery. But unlike other methods, our approach doesn't overlook low-frequency sentences. Instead, it learns the relationships between queries and topics, ensuring that even rare but crucial medical findings are included in the generated reports. This way, we can provide more comprehensive and accurate medical reports. In this slide, we delve deeper into the technical details of our proposed method, teaser. As you can see in the figure, we have visualized and compared the reports generated by our method and other state-of-the-art methods. The sentences, shaded in the same color, correspond to the same topics, and the underlined texts highlight the rare sentences generated by our method. Moving on to the design of our experiments, we evaluated our method on two publicly available datasets, including the MIMIC-CXR dataset. We used several evaluation metrics, including the F1 score, natural language generation, and clinical efficacy metrics. This comprehensive evaluation approach allowed us to thoroughly assess the performance of our method. The figure on the right provides a visual representation of our method's performance. It clearly demonstrates the effectiveness of our approach in generating accurate and comprehensive medical reports. In the next slide, we will discuss the results of our experiments in more detail. Stay tuned. On this slide, we delve into the technical results of our proposed method, teaser. As you can see in the figure on the right, we've compared and visualized the reports generated by our method and other state-of-the-art methods. The sentences, shaded in the same color, correspond to the same topics, providing a clear visual representation of how our method categorizes information. What's particularly noteworthy is the underlined text. These are the rare sentences generated by our method. This highlights teaser's unique ability to not only identify common medical observations, but also to capture crucial, low-frequency findings. This is a significant advancement in medical report generation, addressing a key issue that other methods have not been able to overcome. In essence, our teaser method is designed to generate more accurate and comprehensive medical reports. And as you can see from the figure, it does just that. Moving on to our technical results, let's take a look at this figure on the left. It compares and visualizes the reports generated by our teaser method and other state-of-the-art methods. Notice the sentences, shaded in the same color. They correspond to the same topics, and the underlined text. They highlight the rare sentences generated by our method. Now, let's delve into the implications of these results. Our teaser method has shown a significant improvement in the accuracy and comprehensiveness of medical reports. This is evident from the substantial increase in the F1 score on the MIMIC-CXR dataset. This indicates that teaser is capable of correctly identifying and retrieving relevant sentences for both common and rare topics. Moreover, our method successfully addresses the issue of overlooking rare topics. This means that teaser can potentially improve the detection and reporting of rare but crucial medical findings. And lastly, the ability to generate more accurate and comprehensive reports suggests that teaser can potentially enhance the quality of medical diagnosis and treatment. This is a significant step forward in the field of medical report generation. In conclusion, our paper presents a novel approach to medical report generation, the Topicwise Separable Sentence Retrieval method, or teaser. This method addresses a key issue in the field, the overlooking of rare topics due to data's long-tail distribution. To tackle this, we separate queries into common and rare categories. The common queries are designed to match frequent medical observations, while the rare queries focus on capturing low-frequency but crucial findings. Our approach begins with a vision transformer, or VIT, which extracts dense visual features from a radiological image. These features are then processed by an abstractor, which removes any redundant or irrelevant information. The cleaned-up visual features are then used by the Topicwise Separable encoder to generate diverse topic embeddings. One of the key innovations of our method is the introduction of a Topic Contrastive Loss, or TCL. This aligns similar semantic queries and topics, reducing confusion in matching and improving the accuracy of the generated reports. In essence, our approach provides a comprehensive solution to medical report generation, addressing both common and rare topics and ensuring the accuracy and relevance of the generated reports. Thank you.